All right. Good evening, everyone. I hope everyone is okay. Um, Mr. Senyang here with a topic which is called uh, differentiation. Differentiation from past principles. Differentiation from first principles. Here, under differentiation, we can use a book known as Backhouse. Most especially, we use Backhouse. That is Backhouse 1. It's where we find differentiation from first principles. Yeah, if we can get what we need to know about differentiation from first principles. Here, we differentiate something from scratch. How do we do so? We have a formula for differentiation from first principle which states that f prime of x is equal to limit h tends to 0 f of x plus h then minus f of x then divided by h. Yes, this is the formula that we always use from differentiation from first principles. We can have a simple question here whereby we can try out to overcome a certain problem. Like they can give us a question. Let us get an example here. We can say find from first principles or first principles the derivative of a function f of x is equal to kt to the power 4. Yes. In this matter, where there is x, we can simply put our t, because the question is having t, meaning that it will be f prime of t is equal to limits as h tends to 0 f of t plus h then minus f of t or divided by our h. So what do we do in this case? The first thing is that we have the f of t, and this f of t is the same as kt to the power 4. Okay, sorry, this one was a t. Now then we need to get the f of t plus h. That's another thing. How do we get f of t plus h? Wherever there is t here, it will be our k into t plus h to the power 4. Where there is t, you put t plus h to the power 4. Now here we're going to use the binomial expansion where we have 1, 1, 1, you put a 2, 1, 1, you put 3, 3, 1, 1, means you have a 4, 6, and 4. So this is the power to the power 4 whereby we have to get that expansion. What do we mean by this? The first part, obviously I can put a k outside, then it will come later. So this one, it will be the first thing is t to the power 4, this one. The second one is a 4t. Now the t becomes small, the h starts to expand. Then plus 6, this one. The t starts to decrease, the h increases. Plus, you see this one? That is the 4t becomes 1 now, then h to the power 3, then plus our h to the power 4. So that is the expansion. Now if I happen to put in our k, it will be kt to the power 4 plus 4kt cubed h plus a 6kt squared h squared plus a 4kt h squared plus a k h to the power 4. So this is our f of t plus h, which we're gonna be substituting into our formula. Yes, if we go ahead and substitute into the formula, this formula here, it means that we're gonna say our f prime of t is equal to limits as h tends to 0. Yes, my f of t plus k, this is what I have, kt to the power 4 plus 4 t cubed h plus 6. Sorry, there is a k here. There is a k here which I misfired here. There is a k here, kt cubed h plus 6 kt squared h squared plus 4kt h squared plus kh to the power 4. But don't forget, in the question there is a minus here. Minus, what is my f of t? My f of t is a k t to the power 4. Then divided by our h. Yes, here in the formula. Now let's try to look at, you see this k t to the power 4 is the same as this. They cancel out. So if they cancel out, it means I'm having something of this nature is remaining. F of t limits h tends to 0. We have a 4 kt squared cubed h plus 6 kt squared h squared plus a 4 kt h to the power 4. Sorry, this one is h to the power 3. This one here, h to the power 3, because it increased from 2 to 3. Then plus k h to the power 4 divided by our h. Now what is common? When you try to look at this, our h is common, meaning that if I remove h, it means I'm remaining with 4 kt cubed, the h is out, plus 6 kt squared h, because one h is out, this is h squared, plus 4 t h squared, because the h is out, one which was cubed is now turns to be squared, then k h cubed. All of this, we're gonna divide it by h. You see that our h will be cancelling out. What am I remaining with? Is my f of t is equal to limits as h tends to 0, 4 kt cubed plus 6 kt squared. Where there is h, you put a 0, because they say it here as h tends to 0. Then